Hi everyone, in this video I'll be going over another application problem, going over some of the concepts that we've done so far in the series. So in this particular problem, we're asked to find the tension vector in the two wires that suspends a 1,000 kilogram box. Now we know that the angle between the two wires is 15 degrees and that the wires are identical and of equal length, so we also know that their vector, the tension vector, is going to be identical. Now, since the acceleration due to gravity, 9.8 meters per second squared, is given, and we also know the mass of the box, we can actually go ahead and find the vertical vector. So that vector v is going to be 9.8 meters per second squared times 1,000 to give 9,800 newtons downwards. So let's put it down. And we can now take this this diagram here and draw a simpler diagram as follows. So we can just take the two vectors, the tension vectors, and we'll draw the vertical vector. Now, if we were to take this diagram and rearrange it so that it looks like this, so that's this vector here and this vector there. So let's just extend this a little bit here. And then we take the vertical vector and we draw it so that it looks like this. We realize that the vertical vector is really just a sum, a vector addition of the two tension vectors. And that makes sense because intuitively the tension vectors is what's supporting the vertical vector so that it's actually suspended up in the air. Now, unlike the other problem that we did in the previous video where we simply took the sum of the two vectors and we use the Pythagorean theorem to find the magnitude of this vector, well, we can't do that here because in the previous video, if you remember, what we had was a right triangle. So the resultant vector here, was a sum of two right sides. So in this problem here, we're going to have to employ a different strategy, but because the angle in between the two tension wires is identical, we can then make a deduction that this is indeed an isosceles triangle. So to I guess stress on that point a little bit further, if we actually draw a dotted line here, we know that this is 15 degrees and this is also 15 degrees, and so the total angle here is 30 degrees. Now, using that, we can now figure out the base angles, which is 180 minus 30 over 2, which is 75 degrees. So now we know the base angles, and we know the angle right here, which is 30 degrees. We also know the length or the magnitude of this vector here, the base. So we can now use a really important tool in our mathematical repertoire, which is the Sine Law. So the Sine Law. And what this states is, because I know the base and its opposing angle, I can use that ratio to find another unknown given I know one of the two metrics. So I guess to put that more simply, if I know the the vertical, or I guess if I know the vertical, the magnitude of the vertical vector, which is 9,800 newtons, and I know the angle opposing it, which is, or the sine of the angle opposing it, which is sine of 30 degrees, that ratio is equal to the tension, the magnitude of the tension vector, over the sine of the angle opposing it, which is 75 degrees. Right, so now if I were to solve for this, the magnitude of the tension vector, what I get is simply sine of 75 times 9,800 over the sine of 30 degrees. And if you were to solve this, you would get 18,932 newtons. And just like that, we took what looked like a pretty complex problem because Again, we didn't have that right angle to use the Pythagorean theorem, but we were able to use the sine law to then prove or determine the magnitude of the tension vector. Alright, I hope you enjoyed this video, and let me know how I did. Thank you.